Okay, it looks like it's preparing to send the live stream now on YouTube. Just loading. And yeah, we're live.
Okay, so I think let's get started. Hello, everyone, and welcome to another Rhine Drama seminar talk. So today is my great pleasure to introduce you Benjamin Horne. So Ben is an assistant professor at the University of Tennessee at Knoxville, and he received his PhD in computer science from Rensselaer Polytechnic Institute in New York. And over the past few years, Benjamin did some interesting work related to fake news and provided a bunch of very interesting data sets to the community as well. And today he's gonna talk about tailoring heuristics and timing AI interventions for supporting news veracity assessments. So Ben, please take it right away.
Great, thanks, Savas. So yeah, I'm really happy to be here. I'm a big fan of these seminars, so happy to be participating. Today, I'm going to be talking about a work that's a little different from my normal work. Normally, I'm doing a lot of computational work, and this is much more of a qualitative set of works. But I'll sort of tie into why I think it's important for the computational and sort of measurement aspects of fake news detection. Specifically, this work is a mix of two things. So one, it's a paper that was published in Computers and Human Behavior in December 2020. And then there's sort of a tangent that I'll add in there that's coming out in Communications of the ACM, hopefully next month. You kind of never know with them. So I'll go ahead and get started. So much of sort of this broad area of news veracity assessments and detection has been focused on detecting and characterize quote unquote fake news. And fake news, as you know from the literature, has been sort of defined and utilized in many different ways, all the way from true and false claims to an article that has some sort of misinformation because of hyperpartisan spin, information taken out of context, all sorts of things. And most of this work is focused sort of on the computational side. So can we develop features or algorithms that can ultimately tell us if information is unreliable? This ranges from handcrafted features all the way to sort of automated feature extraction using deep learning, all sorts of things. And ultimately, all of these works together sort of paints this very complex picture of detecting false information, mostly due to the fact that the ground truth can change all the time, right? The difference between a true and false claim and a hyperpartisan news article is very different. And so this has shown mixed success. We have some robust, sort of accurate methods, but there's lots of caveats and concerns, such as how will they work over time, and ultimately how will users interact with them. And so sort of in parallel to this, and maybe even before this, there's been this growing literature on humans interacting with false information without this sort of algorithm as an intervention. And this is a really rich and old literature that is across multiple fields: psychology, communications, information sciences, etc. And so we could spend a whole 40 minutes just talking about this set of literature, but I sort of just want to highlight some of the big conclusions that have came from it. So for example, we know that information is more likely to be accepted when it's consistent with prior beliefs. So this is classically known as confirmation bias. We know that information endorsed by significant others or shared by your friends on a social network is often more believable. We know that we often rely on emotions when assessing fake news, et cetera, et cetera. Right? So there's all sorts of cognitive and social heuristics and things that come into play. And ultimately, this sort of paints this complex picture of humans interacting with information, right? So it's saying that, okay, sometimes we're good at saying when something is true or false, sometimes we're bad at it. It mostly depends on things like your situational perceptions, your prior beliefs, inter-individual differences, things like culture, educational background, all of these things. Ultimately, your trust in media. Do you trust mainstream media to give you information? Sometimes it comes down to your background knowledge, if the topic is very niche, et cetera. Right? So the idea here is we have two sets of literature. one setting on automating this task, the other on how humans are doing the task, and both are sort of giving us these mixed complex results. Now, there's many different suggestions on how to solve this fake news problem across these two literatures, but broadly you can sort of fit them into these three different suggestions or approaches. The first one is to reduce the visibility of unreliable information. So this is classically deranking false or unreliable information by an algorithm or simply filtering it out. We know there's lots of questions sort of ethically there. What happens if we accidentally suppress the wrong news? Lots of different questions there. The second one is sort of the opposite side, which comes more from psychology and communications. How can we, instead of automating this task, can we just educate news consumers to do it better? And hopefully if we educate them, then we won't have to do all this algorithmic filtering, et cetera. And then there's this third one, which is sort of a mix between the two. And that's flagging unreliable information when it's shown to the user. So this is sort of the idea of a warning label. And this warning label can be AI generated or not. It could come from a fact checker, et cetera. And so this is where this broad work is going to focus, is on warning labels. Specifically, we examine two unexplored facets of the effectiveness of warning labels. The first one is the timing of the warning label. So how early in the news cycle do we show this warning label? And you'll see this gets a little complex. So sometimes I'll call it topic novelty because it very much depends on how new the topic is in the news cycle. And then the second one is, rather than giving this generic warning label where we're just saying this is false or this is disputed, can we tailor it to be more specific to decision-making heuristics that we already know are being used when humans are assessing false information? And I'll describe that one as well in just a minute. And so sort of before I get into the main work, I want to say why this is actually an important gap to be studying. From my perspective as a person usually doing the computational side, there's really two main motivations for this work. The first one is sort of obvious. Even if we have perfect systems, if they don't correctly change the perceptions of the consumer, then it doesn't really matter, right? It doesn't matter what you do if it doesn't change perceptions. So this is something we need to understand. And then second, I think maybe more important, at least for me, my perspective, is if we can understand the right outputs, the right warning labels to show users, then this actually can fundamentally change the learning problem, right? So for example, if showing users that there's a true or false claim in an article works better than telling them that it comes from an unreliable source, this changes the ground truth that we're working on, right? In one case, we're working on computational fact checking. The other case, we're sort of doing a weak labeling type of setting. And so understanding this part of the problem actually is going to help us kind of upstream figure out the learning problem. And in addition to this, there's actually not much work on warning labels, especially at the time that this was written. I think there's been a lot more in the past 6 months actually than there was at the time. There's basically two works that showed these type of sort of similar tests that I'm going to show you in warning labels. The first one comes from Moravec et al. 2018. This is a really interesting study. They're using brain patterning and all sorts of things in the study. But the main idea is when they show this generic label, which looks something like this, consumers spent more time considering the veracity of the news they were reading, but they actually didn't improve on judging veracity. So this is sort of showing it doesn't really work. It is changing some timing aspect, but it's not actually changing perceptions. And then secondly, our previous work that was based sort of on this Moravec work, instead of showing a generic label or a generic warning label, we're going to show some sort of probabilistic label of how reliable or unreliable a news article is. And we found that this actually increased consumers' ability to judge veracity, but there are all sorts of problems when you tested this across individual differences. And ultimately, it showed that people who are good at the task just got better, and people who are bad at the task didn't necessarily get significantly better. So we're sort of missing the subset of people that we actually want to help with this task. We also know that warning labels have been implemented in real systems, and we don't really know exactly how they interact with users. At the time when we were writing this, there really wasn't any study, despite the fact that Twitter had put out warning labels at that time. Savas himself came out with a paper pretty recently I thought was pretty great. In high-level idea, it basically paints a picture. This is a complex interaction, right? Users are doing lots of things. There's some effectiveness where people are actually further debunking the claims using Twitter's quoting mechanism. And then you're also seeing people sort of reinforce the false claims. So all of this is to say that this is sort of a complex area that warrants more investigation. Okay, so before I get into sort of the main aspect of using warning labels and changing both the timing and sort of the tailoring of the statement in the warning label, I want to talk about a study, a very brief study that actually informed and sort of motivated the second study. And this is just on simply exploring what heuristics are being used when people are assessing false information. So as I just told you, news veracity decisions are often supported by heuristics or mental shortcuts. And there's many, many different results in this area. However, these results came from many different settings and contexts. So for example, some of them are simply talking about when I select news or when I decide to read it. Some are actually talking about when I evaluate the news credibility. Others are in various different settings, whether that's either on Facebook, on Twitter, reading an individual news article, etc. We also know that some heuristics are better than others, right? So it's much better for me to rely on the source being reliable rather than relying on my prior beliefs. And so substituting sort of these higher level questions for the question of, is this true or false, has very sort of mixed and different context studies. And in fact, many of our automated tools are actually built on these heuristics, but we don't really sort of phrase them like that, right? So all of our features are ultimately sort of shortcuts to approximate how reliable the information is. And so given this sort of complexity of the literature, there wasn't really any one piece of literature to say, here's the heuristics people are using when they're reading news. We decided to try to validate the use of heuristics by news consumers with a qualitative study. And this qualitative study is a very simple setup. Participants read one random article from a data set of 10 news articles, and each of these articles was fact-checked by some third-party fact-checker, Snopes, PolitiFact, etc. And then each article fell into one of two topics, either climate change or vaccinations. Now, importantly, these are not COVID-19 vaccinations because the study actually piloted it in November 2019. So if you can remember, way back before the pandemic, there was a whole different time in vaccination news. This was mostly on measles outbreaks and things of this nature. And so here's just a quick example so you have an idea what these articles look like. Unreliable articles, mostly things on climate change hoaxes. Each one of these, again, had some sort of claim that had been fact-checked. And then reliable articles on things like carbon emissions, measles outbreaks in the US, etc. And so then when each individual is given a news article, they're asked two very simple questions. Do they believe that article and why? And so belief is measured on a 5-point scale to definitely yes, from definitely yes to definitely not. And then we left this sort of open-ended text box to say, why did you choose to believe or not believe that? And so the goal here is to sort of get at the reasoning, not necessarily how correct they were, but why they chose to believe it or not, and try to extract heuristics from that. Ultimately, we ran this study for 3 different rounds. First one, November 2019, the last one, April 2020. You'll probably remember this is sort of crossing the threshold of when COVID-19 sort of broke out in the US. And so we ran this third round sort of as a robustness check to see did sort of reasoning change with these articles, because people's news consumption would probably change when they're at home more often, and sort of their view of vaccination might have changed even at this very early stage in the pandemic. Ultimately, this showed there was no significant difference between these 3 rounds. So it's 3 rounds, same demographics, basically the same said results. And so with these 272 valid responses we got from the study, we take a hypothesis development approach. The idea here is that rather than utilizing the literature to say these are the heuristics that happen, we're going to not use the literature and simply try to come up with broad codes of what the reasoning is behind belief and not believing each of the articles. And then afterwards, you go back to the literature and see how your categories align. This basically comes out in 3 different steps. First, 2 authors individually went over each of the data to identify these broad codes, and you basically continue until you get a stable set of codes. So there's no new categories that are being introduced. Then these 2 original coders and another author individually coded all of the data. So all 272 qualitative open-ended responses. And then you'll see that there's a 81.4% agreement after this round. This pretty good, but we went back, discussed some of the conflicts in the coding. This is sort of standard in hypothesis development, agreed on some stricter definitions, returned to step 2, and ultimately ended up getting a 93% agreement. And so in this short study, we found 9 broad reasonings for believing or not believing in a given news article. The first one is sort of what you would expect based on the literature. That's personal belief alignment, or something what we would call confirmation bias. And this was the vast majority of our responses. 29% of them contained some sort of reasoning that aligned with their beliefs. So some examples: I believe climate change is happening, we're running out of time to try to save our planet, or something as simple as I don't believe in climate change, and that's sort of it. There's not much more reasoning than that. The key here is that they're saying they believe in something, and that belief is what's driving their reasoning, even if it's driving it correct or incorrect, right? They're still relying on their belief. The second one that we found, which happened not much very often, but it was actually pretty interesting, is personal experience alignment. So this is when the respondents mention explicitly that they experienced something, and that is influencing their views on believing or not believing the article. So for example, one of the articles was talking about using essential oils instead of vaccines. And this person said, I believe it because I use the oils and it works. Right? So this is sort of their experience with oils is informing their choice in the article. There's also some on vaccination with chickenpox, because I had chickenpox when I was young. Right? So this is basing on their experience. But this is only a small amount, 3% of the responses. The third one, which I think is sort of complex, is personal knowledge alignment. So often this sort of overlaps with personal belief alignment, because at what point are your beliefs based on your prior knowledge or not? They're sort of overlapping. The difference here in our definition is that there is some explicit pointing to a past piece of factual evidence, whether that's a previous news article or some other factual information that they know. So for example, some people would say, because I've heard a lot about this topic in other news articles, it contradicts things I know are facts, etc. Right? So the reasoning is that the article does not or does align with their knowledge. The fourth one is supporting evidence in the article. This is pretty easy. They would explicitly state that the article gives some sort of source for the information or some sort of quote that is backed up by some other evidence. Bias perception, respondents explicitly said that they perceive the article as biased, and these get all sorts of very, very long responses. Things like this information or news seems very biased against left-wing members of the news. It seems very biased. Funny, they mentioned fake news, et cetera, et cetera. Accuracy perception, response explicitly mentioned that it seems accurate. These are very short usually. It seems accurate. I believe it because it seems factual. Coherent story. This is that there is some sort of logical progression in the story that makes them believe it. So I believe the information in the article because it presents logical arguments, etc. Writing style. This is explicitly mentioning that there's derogatory terms or the writing was very poor, so they don't believe it. So for example, it doesn't use slanted language. So there's sometimes very specific reasonings because of the writing style. And then lastly, trusted source, which happened 14% of the time. This is explicitly mentioning that they trust it because the source is reliable or not. So, sort of long-winded to say that if you, after this study of sort of qualitatively assessing responses and you go back to the literature, you ultimately find that there's three broad sets of heuristics being used. Self or cognitive heuristics, these are personal belief, personal experience. Content heuristics, so my perceptions of the content, whether that's accurate, bias, some sort of error or not error in the writing style. And then the source heuristic. Who wrote it? Are they reliable or not? And we found that the vast majority of responses use this self or cognitive set of heuristics, mostly the personal belief alignment. And so this sort of brings me to the primary study. How can we tailor AI advice given what we know about the heuristics in this decision making? And the main question that sort of motivated this after we did this first study is, can we actually overcome this use of personal belief alignment? So while this personal belief alignment got, sometimes got the correct answer, right? They believed an article that was in fact factual. It was most often used when an article was not factual, right? So this is sort of the negative result of using this heuristic. And the literature also sort of supports this heuristic coming up. So for example, if we go back to the Morvex study I talked about in the beginning, one of the main results from that paper is that the warning flag was not enough to overcome participants' inherent confirmation bias. So our goal here is, can we make a warning label that actually overcomes this confirmation bias? And there's two ways we'll try this, which I mentioned in the beginning. The first way is timing the articles or timing the warning label on the article. So is the news on a familiar topic, or is it on some sort of topic that I don't have a strong prior belief on? And you'll see that this is sort of a opportunistic study here. And then the second is, can we invoke another more useful heuristic rather than personal belief alignment? So rather than saying this is a false article, can we try to tell them to look at the source or look at the accuracy of the article, something that's more useful than their prior belief? Okay, so our general setup for this is exactly the same as this first study. We're going to give participants one random article to read. And we're going to, each of those articles is going to be a fact-checked article, true or false. And we found no significant differences between these two studies, so they're going to be pretty comparable. Importantly, this study ran in April 2020. So this is about a week after that third run, about 6 to 7 weeks away from the beginning of March when the US was getting hit by COVID. And the first intervention that we're going to vary is the timing. And so timing may not be the best word for this, but we really couldn't think of a better one. The two conditions are everyday news, which is going to be the same articles I just showed you on climate change and vaccination. And then we're going to do this other setting, which is sort of the opportunistic part here, which is emerging news. These are fact-checked articles on COVID-19. Right, so this is early enough on in the pandemic that there are fact-checked articles, so we know some facts about it, but it's also early enough that we're not sure people actually have strong beliefs on the veracity of COVID-19 or any of the masking policies, et cetera. And so we'll call these everyday news and emerging news. There's probably a better term for that, but this is sort of a term we came up with at the time. And so here's just an example of the articles we're going to introduce. So again, we still have the same 10 articles from before, and now we're introducing another 10 articles, which are fact-checked on COVID. You can see these are sort of very obvious things like the COVID-19s from 5G cell towers. And then some of the reliable articles are simply reinforcing some of the protective guidelines from WHO at the time. And again, each one of these has some sort of fact-check label with it. The second part of the intervention we're going to sort of move around is this tailoring the warning statement. So the first thing we're going to do is try to tailor it towards the source heuristic. Because we found when the source heuristic was used, it was actually used more often for correct judgments. And so what we're going to put at the top of our news article is this label that says, our smart AI system indicates that this is a trusted news source, or our smart AI system indicates this is not a trusted news source. So this is very subtle, right? This isn't sort of anything complex. We're just adding on this caveat that the reason our AI chose this is because of the news source. The second one is going to try to invoke a content heuristic, because again, this is another class of heuristics that was used more for correct decisions than it was for incorrect decisions. So at the top of our news article, we'll again have a warning label. This time it says our smart AI system rates this article as accurate and reliable or inaccurate and unreliable. Again, both these are very, very simple, small changes to our warning labels, which ultimately would give us this setup of 4 different warning labels with 2 different article conditions. The first one is no AI, so we're just going to give them an article either from this everyday news category or this emerging category where we have COVID-19 news. We'll give them generic warning labels, which just says our AI system believes this article. And so there's no special statement there. It's very generic. And then we'll have our 2 AI source and AI content conditions. So this ultimately gives us 8 total conditions to check. And based on study 1, we're going to hypothesize 2 things. We're first going to hypothesize that the effectiveness of algorithmic advice will be higher in this emerging news category, because we're sort of assuming or hoping that prior beliefs won't be set, thus the warning label will be more effective than it is in this everyday news category on climate change and vaccination, much before sort of the COVID-19 vaccine. The second hypothesis is that the effectiveness of the algorithmic advice will be higher when it's tailored to one of these heuristics, either the source heuristic or this content heuristic, as opposed to this generic warning label. Okay, so this time we ran, again, this study is all in April 2020. It all happened within about a week and a half. In total, we got 1,097 participants. This is quite a bit more participants than you would normally get for a qualitative study, but we wanted to make sure we saturated each of these conditions because there's a lot of them. They're roughly balanced between each of the conditions and each of the article settings. And we're going to ask the same thing. Do they believe it? And why or why not? And so with this belief question, now we can sort of do some quantitative work, very simple quantitative work. We're going to compute the percentage of agreement between the consumer believing that response and the fact check label of the article. We do this by compressing that 5-point scale down to 2 points. So very simply, if they answered definitely not or probably not, this is going to line up with false. If they said definitely yes or probably yes, this will align with true. And then we throw out all the might or might not responses. We'll get back to these might or might not because they're quite interesting. But for this pairwise comparison, we're going to throw those out. So what do we get from this very simple pairwise comparison between all these conditions? The main thing we see here is that AI warnings work, but they're only working if the news is on COVID-19 or in this emerging category. So what you'll see here is the 2 different interventions or settings that are being compared, and then you'll see the percentage that believed, or I guess correctly aligned with the article. So they either believed a true article or did not believe a false article for both of those conditions. And then this is a simple pairwise comparison. So we're seeing how significant those percentages are different. You'll see that in this first category, which is on vaccination and climate change, we see no significant differences. So every single type of AI intervention or warning label doesn't do anything significant. And you'll see almost all of them basically align with each other, 84%, 83% got it correct. And when we switch that then to the emerging category with these COVID-19 articles, we see significance almost across the board. And so between having no AI and a generic label, we can see a jump from 72% correctly believing or not believing in the article to 84%. If you do this with any of our sort of tailored AI labels, you also see this jump, but even bigger, all the way up to 93%. You can also see that there's significant differences between the generic AI warning and these tailored warnings, going from the 84-ish% all the way up to 93%. And so this is sort of surprising, right? We didn't think that this was actually going to happen. Like, yes, we hypothesized this would be some significance, but not this high of significance across the board, especially compared to everyday news, where it seemed everyone was sort of stable in their beliefs. And so this is an interesting result, but it's actually kind of hard to explain, right? So looking back at our hypotheses, hypothesis one is supported, right? The emerging news situation is definitely a more pliable situation to influence consumer perceptions. Hypothesis two is sort of partially supported, right? These tailored warning labels did nothing when there were already prior beliefs set or sort of on these old topics that have been reported on often in the past. And so there's lots of ways to try to explain this. The first way is sort of going back to our hypotheses that maybe in the emerging situation, confirmation bias is simply not coming into play because there's no stronger prior beliefs on COVID-19 at the time. And you can sort of look at this when we recode all the results back into our categories. You can see that personal belief alignment actually doesn't change. It, in fact, increases by 1%, although that's not significant. But the overall distribution of heuristics being used in the reasoning does change. So for example, we see a huge reduction in bias perception. So it's very rare that when reading a COVID-19 article, the consumer said they perceived it to be biased. We see an increase in accuracy perception, right? So when they're reading a COVID-19 article, they either perceive it to be factual or not. We also saw a huge increase in coherent stories. So saying, this makes sense to me, this is logical, thus I believe it. And then we see an increase in trusted source. So this sort of jump back to, I don't know anything about COVID-19 right now, but it's from, say, NPR, so I trust the source. The other more significant finding is that the number of heuristics being used is actually more, and significantly more if you put this between a pairwise chi-square test. So in the everyday news setting, about 1.1 heuristics were used per article. So this is how many reasonings I choose in my open-ended question, all the way up to 1.3 on average for emerging news. And you can sort of see these responses qualitatively. And again, this is maybe not going to explain this very well, but it gives you some pointing to some explanations. So in the open text responses in the everyday news category, we definitely see lots of evidence of these cognitive heuristics happening. So for example, this one's on an article from Climate Change saying, I don't believe that global warming is made up. And you see the scientific consensus is very strong. So they're using past knowledge alignment and past belief alignment. You can also see sort of the opposite side, that right away global warming and climate change are lies, and then sort of a long spiel about various sort of conspiracy theories and incorrect facts that they're relying on. So this is sort of aligning with confirmation bias, and this happens a lot in the everyday news category. On the other hand, just as the stats showed, in the emerging news category, we do see this personal belief alignment, but we often see it paired with lots of other heuristics. So they're sort of going down the line of, here's all the reasons I could choose to believe or not believe this. So for example, we can see no evidence in the article, frequent unnecessary capital letters, this is writing style, lack of sources, writing is poor, meant to scare, fake tone, ridiculous claims, right? So there's jumping around to all sorts of reasonings. You can see this here as well. The language is hinting that it's going to be an unreliable article. Some technical words are used, so it's sort of hinting that it may be reliable. Overall impression is amateur. And you can see the same thing here. Article seems credible and factual, right? So this is sort of an accuracy perception. Then there's some based on their knowledge. They know there's been shortage of PPE, so it seems legitimate. Then you can see them sort of jump to, I trust this source, thus maybe it's reliable and accurate, etc. The open text responses also showed sort of what you would expect, right? An increase in uncertainty in the COVID-19 articles. So, for example, some of them would say something like, I mean, at this point, anything is possible. This respondent said they might or might not believe the article, which was labeled as false. I really do not know enough about chemistry or biology or whatever field of science this is to know if it's true or not. This respondent said they probably do not believe the article that was marked as false. And there's many responses sort of throwing up their hands and saying, I don't know. And if you look at the category of might or might not, it increased from 16% in the everyday category to 25% in this COVID-19 article category. So this combination result shows, okay, confirmation bias is sort of happening in both, or this sort of personal belief alignment, but in the COVID-19 news, they're often more uncertain and they're often relying on a variety of heuristics rather than just one prior belief. Lastly, one thing you do see, which I think is sort of good for computational work, is that the AI warning is being used explicitly often in the reasoning behind believing or not. So you can see that they have lots of different heuristics being used first. So they think the information is inaccurate, it's a conspiracy theory, heavily biased language, etc. And then they say the article is rated as not trusted news source by this AI. So you can see that this is sort of actually being used in reasoning, although in pairing with many other pieces of reasoning. And we find this pretty frequently throughout all of the warning labels. Interestingly, we do see that when you tailor the warning label to one of the source or content heuristics, we saw more heuristics using source credibility in the source treatment than if not. And we saw more using content heuristics such as accuracy perception when we gave the AI content treatment. And so seeing that there is some significant shift in reasoning is a good sign for us doing automated work, right? This warning labels have some effect, and tailoring them is actually changing reasoning with some significance. So this is sort of a complex study, right? And you see some explanation for the results, but also there's a lot of sort of caveats to it. The two major takeaways that I would take from this work is that the novelty of the news topic does have significant impact on both the heuristics used, so what's my reasoning for believing, and their actual willingness to use this AI warning. When there is high uncertainty, it seems that warning labels are more accepted. And tailoring the warnings to trigger some sort of good heuristic rather than a personal belief heuristic does work, but not all the time, right? When it's only in high uncertainty situations like these COVID-19 articles. And then this result here in particular is actually supported by some recent work by Pennycook and Rand, where they show if you tell a user to pay attention to accuracy, that they end up being better at judging the accuracy of the article. This is a very similar sort of result. If I nudge users to focus on accuracy or these content heuristics, they usually do a little bit better. So I'm about at 40 minutes. So to wrap up, there's clearly lots of limitations here. As I said, sort of this timing or novelty effect is not fully explained, right? We sort of think confirmation bias plays a role, but it definitely doesn't explain it at all. We know that Amazon Mechanical Turk can be a bias sample of digitally literate populations. You'll notice that most of the participants actually got the correct answer when saying they believe or not believe. And so this may not be the right population to fully analyze these warning labels, right? We're sort of getting a more digitally literate population, thus things may be more effective than they would in another population. Importantly, the AI warning is a one-time interaction. There's lots of concerns in the literature about what happens over repeated exposure. Does that change behavior for the better or for the worse? And then finally, our study is in an active environment, which I think is really important, right? So we're telling them to read a news article and they're fully reading it and giving us reasoning. Whereas if I'm on a social network, I'm often scrolling past these things sort of passively. And if I see a warning label in passing, that doesn't necessarily mean I don't store that information as true. So there's sort of a complex environment here that needs to be tested. And then, of course, there's many other facets that we don't test here. This is sort of just one small part of that gap, hopefully to help build correct computational models and outputs. So I think I hit like right at 40 minutes, pretty close. So any questions? These are the two papers that it comes from, and I'd be happy to discuss any sort of caveats of this work.
Okay, thanks a lot, Bern, for a very interesting talk. So let's all virtually, let's say, applaud Bern for the great talk. So Anton is